Hello, in our today's video we'll have a look at analog to digital conversions. Let's go to our schematics. So what we'll be doing today is we have our 1 kilo ohm potentiometer pot connected, output of that potentiometer is connected to PA02 pin, and that pot is fed from our 5 volts bus. We'll have a look at how this 5 volts bus is set up in a second. Apart from this connection, there's our standard reset switch and power up. So let's go to our MP Lab. Let's create a new project. MP Lab Harmony project. I'm happy with this. Now I'm gonna call this project ADC, just simple. Next. Then in here is just to select our PIC, which is this one, and finish. Now let's launch the Harmony. Once the configurator is loaded, we can set up our modules, peripheral modules that we will use in our project. Let's go to MHC first, tools and pin. So we have pin settings as well. I like to look at the pin settings and set them up first in here. Let's go to the datasheet for our board. In here, let's go to hardware section and let's have a look what are we gonna use from this. Okay, so we will take our 5 volts from the V bus pin. That's going to be fed in my 5 volts bus. Then we have our PA02 pin, which is ADC input 0. We have to remember that. Okay, and apart from that, that's all we can see on this board, what we're going to be using. Oh, no, sorry. We will still use Sercom1 to connect to our terminal. The values, converted values, we will display on the USB terminal. So we will set up those pins as a USB terminal communication. If you are unfamiliar with how to set up the TeraTerm, I invite you to watch the previous tutorial where we setting it up from the scratch. Okay, let's go to PA00. That is going to be my Sercom1 pad 0. Then Sercom1 pad 1 is on the PA02, and as we said, PA01, sorry, Sercom1. Then on the PA02, it's going to be our analog input 2. Which analog input 0. Yes, this is the one, analog input 0. Then what we also need is our voltage reference, 5 volts reference. To find out which pin we can use, let's go to the datasheet for the actual microcontroller, and in here let's go to pinout and packaging. Let's expand that. Then we have to go to our PIC32 pin. Okay, we see ADC 0 module that we'll be using. We have PA02 analog input 0 that we will use, and then we will use reference voltage VREF-A. That is on the pin PA03. Be careful, do not use VREF-B, as that one is reserved for Sigma Delta analog to digital converters, and we will not be discussing that in today's video. Let's go back to MP Lab. So we know PA03 is going to be our voltage reference A, and that's what I'm going to set here. That's all the pins set. Now let's go to the project graph, and in here let's start with the Sercom communication for our terminal. Let's go to peripherals. Then we're looking for a serial communication, Sercom 1. I'm going to drag this here. Okay, let's click on this. Expand the options. We leave in this almost everything as it is. Apart from, we need to change pads. So let's go maybe to pin settings. As you see, Sercom 1 pad 0. It's not telling us in here, but if we go to the device, pad 0 is used for a transmit, and we have to remember that pad 0 is a transmit, pad 1 is a receive. let's go here, and then pad 0 is data reception, which is wrong. We have to change this. So pad 1 is data reception, and in here pad 0 is transmit. So that's the setting where we have to remember to change it. Other than that, this is complete. Still, we will use one more module, which is in tools, actually tool, STDIO. We drag it here and we will connect it to the UART. This will help us to use the printf instruction where we send in the text to the console. Okay, SERCOM1 is set. Now let's have a look at our actual analog to digital conversion. There we have the modules. Let's expand that. And on this chip, we have access to two converters. We will use ADC 0. I'm going to maybe place it here. Now, in here, I'm going to expand the options. We will not be discussing all of them, what is happening, but slowly we will touch on, because I'm planning to make some more videos on ADC, follow up on this one. Okay, so let's start. This is actually very good settings for the conversion rates, samples conversion rate. So I'm not going to change that. Now our reference, our voltage reference, we are using, like we said, external voltage reference A. So we have to select that. Then in here, we've got few options how to trigger the sample conversion, and we will leave it for a moment on a free run. Then channel configuration, differential mode. So this is if you're using a negative voltage as well. We are not using that. Now positive input, we've got all of our pins available in here. And we are using the channel 0. So analog input 0 pin. Results configuration, we leave it at 12-bit. There are different resolutions in here. So we will leave at that. I'm not selecting any other options in here. Later on, like I said, we will touch on interrupts and other events, as well as window mode and how it's converted in a sleep mode when the PIC is actually in a sleep mode, but the conversions are still happening. So we are happy now with all these settings in here. We can go now. Let's have a look again, and that is a free run. Yes. Let's go and generate the code. Generate. Okay, let's wait for this to happen. Great. Now we can go to our project, then source file and main C. I'm going to open the main file. So as you know, this is what we get at the startup. Let's go to the properties of our PIC, of our project actually. So I'm going to click in here in properties, project properties, because we need to select our board, what we're using for this lab. And we have our Curiosity Nano board. Let's confirm the compiler as well and click apply. And okay. So now the hardware is connected. Let me type in a code in there, and I will explain to you what is happening. Our program is ready. In here we have include section where we include in some header files. Then we define in our vref A, which is 5.3. That's what I measured on the bus. If I remember, we'll measure it in a second. Then we declare in a couple variables. We declare in a raw data and a voltage variable. Then in our main section, we have system initialize. Then we are enabling the ADC 0. Actually, let's stop here for a moment. Let's go into all the functions that we can use for the ADC 0 converters. So starting from this section, we have ADC 0 initialize. We've got actually quite a few functions for this converter that we can use in our program. We're not going to use all of them, but as you know, there is a file where if you're unsure about how the function is called, you can go and have a look. So that's where it's all stored, all of those. Some of them we will use, some of them we will touch on the next videos. But there is quite vast amount of functions that can help us with our labs, with our projects. Let's go back to main C. So we are enabling our converter in here, and then in our while loop we are gathering the data from the conversion into our declared raw data. Then to calculate the voltage, we are using this formula, and this is the formula to calculate the voltage based on the 12-bit results as we said before. And then printf function allows us to print that text to the console, and in here we are displaying the actual values that are calculated for the voltage. So pretty simple. Let's have a look at the hardware connections. On our board, what we can see is we've got our pot that is feeding the analog value into the pin number PA2 on the board. We have our voltage reference 5 volts from here, which is taken from this pin on our nano board, and this is just a reset switch. So not much to this. Let's have a look. Maybe first I'll try to connect the multimeter, so we will check our reference voltage. Let's check the voltage on our reference bus, and we can see it's about, I'm having like 5.32, 5.3 volts. Now let's go and program our microcontroller. Once that's complete, let's go to our Tera term, and in here let's go to serial port COM3, click OK, and you can see straight away something is happening but not correct. This is easy to correct. Let's go to setup, serial port, and the speed of our communication is 115/200, and new setting. I'm just gonna lift this up to refresh the screen, and we can see the value is displayed of our actual voltage. All this blinking cursor is actually the speed of the data receiving. So because we do not use any delay at the end of the function, this is working at the full 48 megahertz speed clock, so it's pretty fast. Let's now have a look on our pot. If we turn it, we would expect the value to change because the analog input on that pin is gonna be different. And we're decreasing towards the ground, and as we turn the other way towards the VDD, we should see our voltage going up. Okay, 3, 4. I'm gonna go to maximum. There was a lost connection. Let me just refresh the terminal. There we go. So I'm getting about 5.28 to 29, which is pretty good. It's pretty good. I'm quite happy with that conversion. So that's how we do it. Let's leave it for about 4 volts, because at this moment, what I would like to just show you quickly is one of the settings in our ADC converter. As we have it in a free run, sometimes you might notice that your program is not behaving as expected. There are no results for the conversion. So let's change this to SW trigger, which is a software trigger. Generate the code in here and generate. Let's wait for this to pass. Okay, let's program our microcontroller again. I'm gonna get the terminal ready, and once this is erasing, I'm just gonna refresh. There we go. So we're waiting for the new values to be displayed. I'm gonna bring this down, and now you can see that you don't have any voltage there. There is no readings. Why is this happening? Because now in software trigger, our program, as expected, is waiting for the command to start the conversion. Let's minimize that. In here, now, what we have to do is we have to add the line, or let's go and actually to those commands for the ADC. Okay, so we're using this one to get our conversions results, but what I'm looking for is start the conversion. Is it a little bit higher? Okay, so this is the function that we have to use to start the conversion based on the software trigger. Let's copy that into our main in here. I'm going to paste that in here. We're not passing anything, so let's leave it as so and close the statement. And now let's program the PIC again and have a look what is happening. Once it's gonna go to erasing mode, then I will just refresh the screen so we get the correct data here. Now we've got our values again in a software trigger. Please remember to start the conversion. So that's how we can read the analog input. Obviously, this potentiometer, this pot, is representing any analog value, but usually this will be like a different device giving you analog input to your device, and that data that we're receiving on the terminal would be used for different conversions. Have I lost the connection here? There. Okay. So let's I'm using a metal screwdriver and I'm causing a little bit short circuit there, so that's why it's happening. Let's now leave this one. I hope you guys understand it. Again, if not, you got any questions, please ask below. Let's create another project, little bit more complicated, maybe, let's say, but we can see how we can use the analog to digital converter. In this project, we're using 3 potentiometers, 3 pots, and they are all connected to 3.3. That is analog voltage now. Then on the other side, we've got the ground. They're connected through the switches, each pot, and going into the common PA02 pin, which is our analog input 0. On the other side in here, we can see 3 resistors, which are current limiting resistors to our LEDs, 3 of them and 3 of each different color. Let's go to MP Lab. In here, we can see in our ADC 0 module, I've changed the reference to VDD analog, and I went back to the free run. Still have a ADC input 0 pin. On our pin section, let's go to pin settings. I have added the LED output pins, blue, orange and green LED, all as a GPIOs, all outputs, and starting value as low. Okay, let's go to the code. We still have the same include section, the same section in here with the define and different declarations. Then we have our main section. In here, in a while loop, I have commented out that conversion start, just to show you that we do not need this for the free run. Then we start in our conversion. We get our voltage value. That voltage value gets compared in those 3 statements. So based on the value of our preset known value potentiometers, we comparing it. If it's this, if it falls within this range, then the blue LED is going to be set, all the other ones clear. And in here, we're comparing it against those values, and in this statement against those values. Respectively, the green LED and the orange LED, it's gonna light up. We're still printing the input voltage value onto our terminal. Let's go I'm just gonna keep it here. Let's go program our PIC and wait for it to be done. The PIC is programming is complete. Let's minimize that. Let's go to our hardware. At the moment, nothing is happening. I have reduced the light, so our project is a little bit clearer. I have my LEDs in here. There are 3 different LEDs. Then we have our 3 pots, 1, 2, 3, and they are connected through the switches. As you can see, the value on those potentiometers is different. And these are the pots, these are the switches connected to the same analog input 0 value here. The only difference what you can see is we are not using the voltage reference here now, because we're using the internal voltage analog voltage. Okay, the PIC has been programmed. I'm just going to bring up the console before we start doing anything. So let's reset that. Okay, now as we said, we have our code in here. Let's press the first switch and we have the blue LED on. The value is 3 volts. So again, the 3 volts is compared against this. We see it falls within this bracket. Blue LED is set and the rest of them are clear. The set is permanent, so if I take my finger off, that LED is on permanently now. Let's press a different switch. Okay, so I'm just going to press it again to hold that we have a value of 2.5 volts. Falls within that bracket, which indicates that the green LED should be set on. And then we have our last LED with the orange, let me just put it there, orange LED on. I'm going to hold it for a moment and we have about 1 volt there. Falls within this bracket as expected, orange LED on, rest of them clear. We can keep pressing the buttons and the LEDs will change according to which button we press. This is the tutorial for our analog to digital converters, how we read the values from there. If you have any questions, please post them underneath this video and we will take it from there. Otherwise, I'm inviting you to the next video, which was going to be a continuation to analog to digital conversions. It's going to be actually a project. Thank you very much, and I will see you in the next video. Thank you. Bye.